Now, I guess the first thing I want to do is share my screen, full screen.
Okay, well, let me tell you that, so we need to, when you're done, okay?
Making me stand by for 5 minutes thinking you too.
Infinite regression. Okay.
The infinite regression, yes. There's got to be a scene in the Matrix about this. All right, so I'm going to start the Arduino.
Okay, so it's a little bit time delay.
I was gonna say, who's talking?
Yeah. There's a little bit time delay.
I am speaking. There's a time delay, is there?
Mm-hmm.
Okay. So help getting started. Somewhere in here there's a. So now Arduino. Getting started with Arduino on Windows. Get an Arduino board. Install the drivers.
Minute
You
and
have
a half time
like a
delay.
minute
Okay.
minute and a half time delay.
Oh,
I was like, dude, this is a big time.
Exactly.
that's interesting because I'm going to be getting questions. Okay, so we're going to open the file Blink and see how well it goes. So, file, open.
Example. Basics.
I think I actually, examples, basics, Blink. Okay, so tools, let's see if it's actually hooked up. Board, serial port. Really? It says it has an Arduino Uno. I guess. Well, let's see. Um, so, upload. So it says Arduino Uno on COM4. And of course, the bad news is it was already blinking. I have a feeling that Blink was the last program loaded on.
That's blinking right now.
Huh?
It's blinking right now.
Yes, it was already blinking.
We can also reset it.
Um, okay. That's. I'm getting really frustrated here. Um, it says it has an Arduino Uno on COM4.
I think that's possibly what it's been told. Like that's what's in the settings.
It might need to be reset. So remembering wherever they connected it on the last.
So if you just go to Tools and you look at the serial port, and then you unplug the Arduino,
Okay.
whichever one disappears, the one it should.
thing I don't understand is that when we had this loaded the last time on this computer, I don't think it's COM3. I will try COM5.
You know, at the bottom it says Arduino Uno from COM5.
Oh.
Doesn't work.
Okay, so this time it worked. Of course, it was already
It's already been
blinking.
You could change the delay.
Yes, let us change the delay, and should we make it longer?
I think shorter would be easier to
See.
notice the difference.
Okay. So we will go to half a second. Much shorter than that, and we wouldn't be able to see it. It would just sort of become fade. So let's see, file, save. Okay. Whatever.
Do you need to save before exporting or uploading?
Or you can just copy it, check up your own. Get it through.
You always should. That's good coding hygiene.
Sorry, I didn't even realize the example was on there. I found it. I did that.
Okay, it's working. It's sped up. All right, now. Okay, so this I guess is the Arduino equivalent of Hello World, although I think you guys are supposed to actually do a Hello World program. Anybody got their homework in terms of?
I did it. I don't have it saved on my computer, so no.
Okay, well, since this is the last class, we will have a class in 2 weeks on the 30th. The okay, the let's look through the code. One of the things that's really important when you're writing code, the first step has to be to figure out what you're going to do. So before you learn any specific language, you have to learn how to write a flowchart. And I'm going to use this to give you some idea about that as a first start. Now, at the top of any flowchart, the flowcharts are written in symbols. symbolic boxes, and the shape of the box tells you what's going on. And honestly, I don't actually remember the exact formal that was not cool. I don't remember the exact formal box descriptions that are used around here, but typically the key box is the lozenge or diamond. That is a question or a test, and depending on the outcome of the question, the flow of the program will branch. Now, the program always starts with a now the convention I don't remember is there's a difference between an oval box and a square box, and one is do something internally and the other is do I/O, and I forget which is which. So I won't, because it doesn't really matter if you're only writing for yourself. The only time that convention matters is if you're writing for a big team. So somebody could look that up because we are writing for a big team.
I have a question. How do you know the order is supposed to proceed? Like,
You have to figure it out.
okay, because I have my diagram for what I would like to put the parts on, but I wouldn't know how to go about starting which one should be first with this program.
It has to be dictated by the logic of what you're trying to do.
Okay. So,
And that's actually an impossible question. What comes first is illustrated here. The first thing you have to do is to define and initialize variables. And how picky you have to be about doing that first, or if you can do that in the middle of the program.
That's what I also mean. Like let's say I started working on a program for the weather shield, and then I start working on a program for the GPS shield. There has to be an order for one goes before the other. I mean, you can't just stick them together, right?
You have to think that through. I mean, I'm not even sure we'll ever use the GPS shield. I don't know what we need it for.
Use the GPS on it.
We have other independent GPSs that separately transmit the GPS data.
So that's two. We have two now.
We are going to have two already.
Well, then it's three, Dr. Dunn. We're going to find it.
You have to make those decisions. Okay, that's completely irrelevant to what I'm talking about. I'm talking about at a very different level of coding. I'm talking about the very first box before you get into the process of the program is to set things up. And now the way this works, they've done something with this language that's very specialized. They have told you where all the code is. The very first box is define variables. The second box is actually get the machine configured the way you want it. And what I'm seeing here is that the routine setup, the name itself is telling the compiler and the loader something. That you don't get to call your initial setup anything except setup. That's a defined name. Okay? Now, what this does is it simply says to the computer, pin 13 is an output. Then loop. I was puzzled by this when I first read it. Loop is actually a defined purpose box or subroutine or procedure. Loop says if you call your routine loop, it runs over and over and over again. And you don't have to put in a while statement or any of those other things that make it run over and over and over again. And so the flowchart is actually interesting because there's no test involved. Go back to beginning, do over, is simply not there. Okay, so loop is a predefined routine that loops. Most of what we write will be inside loop. This is good for us because what you're going to want to have is everything running inside loop. And your setup should be fairly simple. So then this does four things. It writes a single bit to pin 13. And it doesn't even let you think about it. You know, is it 1? Is it 0? It actually defines for you high. And low. Now that's actually probably because the pin is an output pin. Okay, so I wish, oh, chat. Let me go. There is control room, cameraman, screen share, chat.
It was already up.
It was?
Yes.
Oh. Okay. I'm sitting here looking for questions. There are no questions. We only have one viewer. Okay. So I'm going to go back over to this window, and now we have gone through all of this. Now, okay, this is not exactly what I was hoping for. I was hoping for a much longer tutorial about various phases of the programming languages, which is what you usually find. Getting started. Okay, so there are examples, foundations, hacking, and links. Okay, so all right, so the basics. Let's look at bare minimum. So we'll go over here. We will open. Where was it that I found?
Example.
That's the bare minimum. Okay, I've already explained that part. The Arduino language has been sharply simplified. Okay, so of digital read serial. Reads digital input on pin 2 and really? It has a button? Okay, so push button equals pin 2. And button state equals digital read push button. Is there a button here on pin 2? Well, let's tools. I want to see tools. Serial monitor, Control Shift N. So now, Control Shift M. There is the serial monitor, and it is belting the living shit out of 0. Hmm. That's what these puppies are for. Yep. Q. Okay, so we should go over here to, what is probably the input it wants, 5 or 3?
Input what?
What is the input I should use, 5 or 3?
I don't know.
Hmm? All right, so now it is belting out 1s to beat the band. It should still be belting out 1s. Yes, it is. So now I have to go ground it. It goes to 0. So we have successfully read the living bejesus out of a digital input. Okay, and we have successfully located and operated the, so what, the Arduino actually has a terminal, and you can see its inputs and outputs. And that is achieved by pressing Control-Shift-M, and it opens the window. Which is good, because I was afraid we'd have to program that, which is ugly. It tells you.
I know, I thought you just pushed the little picture with the page on it. And
Tools, okay. There it is, serial monitor, Control-Shift-M. Okay? The picture with the page on it is a new editor window. All right, so Now let's go back to what are we supposed to do next? I actually wish that there were some people on this hangout, because I'm willing to bet that some of the people who have never done anything with a computer except, drop it when they were 5 and get emotionally scarred and therefore scared of them. If the computer reaches out to strangle you, the escape key and then back slowly away. It is probably okay. So let me go back to learn the basics. The next one is analog read serial. Read a potentiometer, prints its state out to the Arduino serial monitor. Fade, read analog voltage. So we can sit here and go through this. The next one is analog read serial. Let's go back to digital read serial. This is a very that they did something here that some programming languages would beat you upside the head for.
This is really difficult to that bad.
Huh?
It's not as bad as, well, it's really similar to MATLAB, so it's not too bad.
I learned C++.
The variable button state is being defined and initialized by declaring an int here. And that's actually slightly inefficient. Although it may be necessary in this language. They may require you to do it that way. A lot of languages, you define button state as an int and maybe set it to 0 up in setup, and then just say button state equals digital read push button. It's possible that the type definition being endlessly repeated is actually required. It strikes me as sort of stupid, but so this actually writes to the monitor. So actually, it looks like
Is there any way we can attach a multiplexer and something to that so we can see?
not in 20 minutes.
Okay, maybe next time so I can bring it down.
Next time we will not have a class next Monday. It'll be 2 weeks.
Okay.
Did we ever order a multiplexer?
Well, I have the one that Dr. Leffert allows us to use, so we can,
okay.
I could bring it down and bring it back up.
We actually need to get that ordered pretty soon.
With the Arduino Shield, the ADC, the one we got, has a multiplexer built in. So Dr. Leffert said that one should be okay.
I didn't. I said the opposite.
Okay, but we still know where to get one. We can find one. That's not a problem.
I want either an 8-in or I don't think we need I actually don't think we need 16-in, but you need 8-in. But well, let's put it this way: Chris's experiment needs 16.
Mm-hmm.
Yeah. Okay. So 16-in, 16-bit is what you really need. And I have not backed off on that.
I've had a lot of problem finding 16 and 16.
You're not supposed to be looking for it. That's Chris's job.
Oh yeah, we were looking at it together as a team because we're supposed to look at things together.
Okay.
And We really couldn't find now. We could only find.
But the 16 by 24, if for $50, is worth getting. If you can't, it's better to go ahead and order that and not waste time than it is to spend weeks looking for something that turns out not to
Right,
exist.
I already ordered that. I already ordered the new one. Just mentioning that. So we
All right.
will find
So analog read serial is where we want to go next. So let's file close. File examples, basics. See, they have a lot of examples. And strings, USB, communication control. So I think by the time you work through these examples, we'll have go-bys for almost everything you need to do, except thinking through the process.
As soon as most of my team is here this week, I want to get started. I know most of our parts are already here, but I don't want to attempt it by myself, so I have to kind of wait for that.
Well, maybe you should sit with me tomorrow or something and define what get started means. Our focus now has to be on one thing, and one thing only, and that is getting an experiment ready to go for the 1st of August. So that means that building that relay driver, picking relays to order, and getting one Arduino with just weather sensors working and producing a telemetry data frame. And if the TEC guys are ready, you can add their bit stream to the telemetry data frame. But there's no real need for GPS. You do not have to have GPS on this. It's being tracked out the wazoo by
Everything else.
by the CSPF.
Okay.
It's probably going to be sitting underneath the payload, so the GPS won't work.
Yeah, well, I could still use that for the latex radio song. So
Yes, but we don't need to work on that now.
No, I'm not going to work on it. I can put it on the side, but it's still a good piece. So.
Okay, so this is analog read serial. So here's where you put in the baud rate. Serial.begin. Okay, do we happen to have a potentiometer in this bag? Or do I need to get one? I somehow have a sense that anybody have a potentiometer handy? Mm-hmm.
Everyone in the other lab, there should be, right?
Racks and racks and racks. Yeah, we have drawers of them.
Okay. Better go look for one?
Yeah, if you know what they look like.
I just looked up what they look like.
Oh,
Yeah.
most of the ones I have look like little blue boxes about this big.
Okay.
With screws. So an analog input on pin 0 prints the results to the serial monitor. Attach the center of pin to pin A0 and the outside pins to +5 and ground. This example code is in the... So this sets the serial communication at 9600. The loop runs forever. We read an input on analog pin 0, and then it prints out what we read. Okay, so we can actually go ahead and do this. We probably don't need the potentiometer because there are enough voltages on there that it will work. So let's go ahead and upload that puppy. So the real problem you guys are going to face is not so much, I have a feeling that there are go-bys for virtually everything you need to do. If not in the startup tools here, in the documentation that comes with each of the shields.
Is that versus delay, the one, is that a time, like an amount, 1 second?
That's 1 millisecond.
1 millisecond, okay, so, like if you wanted 1 second,
It'd be 1,000.
you would put one, okay.
I mean, that's what we did in Blink. Blink, that is, dude, this is what is known in the trade as a switch. A switch.
I see. I didn't notice it moved up and down.
Okay. Yeah.
That's an SPDT.
Yeah.
Yeah, besides, that nomenclature is used for switches as well as relays. Relays are switches with power. Okay, so this is now should be running. So Control Shift M. It doesn't seem to be working. Oh, there it is. It's giving zeros out the wazoo. Well, let's do something like that. So now we have a value. Now the value is a digital value that isn't in volts. It reads, you'd have to figure out what the calibration is. So if I were to oops, I missed.
Oh, that's 23.
Yeah, so this is a 10-bit digitizer. It goes, I think that's to make life easy for the mathematically challenged. It goes to 0 to 1,000. So you can do calibrations in your head. One bit is 5 millivolts.
One bit is 5.
Oh.
As this is currently configured, that is a very plastic statement.
Yes, some notes.
Well, it's 2 to the 10th, which is 1024, and the digitization goes from 0. The biggest number you can read is actually 2 to the 10th minus 1, or 1023. So that's maxed out, and that is 5 volts. So we know that if we divide 5 by 1023, you get that 1 is approximately 5 millivolts, a skosh under. So we're now looking at 694 millivolts, which works out to be about 3.3 volts. 694 times 0.005. It's okay, we're making do with DC levels.
I think I got it.
Yes, but the problem is I have no actual way. First off, that's a screw-driven one rather than a knob. And secondly, we have them out there with knobs. And secondly,
They all look the same, don't they?
wire.
Okay.
I mean, it's all right. It would. I knew you were going to hit that wall. But
I tried.
Yeah, that'll be right.
there probably are some out there that are wired. They come in a whole huge variety of shapes and sizes. Anyhow, we were just illustrating. This is 3.3 volts in, and the digitizer calibration is drifting over time. That is 5 volts in, and that's maxed out at 1023, that's saturated. And this is ground in, so we have 0 as the output. So eventually we're going to have to start reading the descriptions and definitions. You want this?
No, I'm just looking at how it's make sure I'm looking at the pins and everything correct.
So the next example we want to use is fade. I'm not really explaining much of the code. Okay, this example shows how to fade an LED on pin 9 using the analog write function.
First of all, what is a fade? Huh?
Can we make it less
Just fading out?
Yeah.
Okay, but I mean, like, what do you mean by this? I mean, like, what do you mean by it? Okay, so
I'm thinking here, okay,
I mean, fade out? You're gonna turn it off? Are you gonna, like, slowly dim out and shut down? What is fading? You just dim out and then come back? Or?
Whichever one you want.
Okay.
this example shows how to fade an LED. You get to choose all those things. Those are parts that you can stick into your program.
Okay.
Fade here is being used in the everyday language sense of the word, as in softly fades the light of day.
Okay. Okay.
Have I dared and have I tried my very best to be prepared? Anyway, you didn't sign up for this to hear me sing Scout Vespers badly.
Never.
Guys, would you throw him out the window? Sacrilege! The best possible way to learn to be a functioning engineer is to have been a scout. And that's something that people don't understand. The scouting programs, both Boy Scout and Girl Scout, teach how to do stuff. So we are defining 3 variables. LED equals 9, brightness equals 0, and fade amount equals 5. Now, analog write, LED, comma, brightness. Brightness equals brightness plus fade amount. If brightness equals 0, or brightness is equal 255, fade amount equals minus fade amount. Wait 30 milliseconds for the dimming effect. Okay, so this is an example of an if statement, which is the key thing to learn about programming. It's the lozenge in the flowchart. What is this asking? If it's off
Or on.
or all the way on, don't interrupt me, please. I allow more than you do for the people to take notes. It's not that I don't know what to say, it's that I'm waiting for them to have time to take notes. When you're my age, that becomes such a deep habit, I can't get a word in edgewise. Those of you who actually conversed with my wife on Saturday, you realize she talks a lot. It's okay. I'm okay with that. I don't have anything to say anyway. So you change the sign of fade amount. So this is actually going to turn on rather than turn off. I probably ought to take this out. And now let's upload the program. So we're illustrating for the first time an if statement. And now you can see that if we have a delay other than 1,500 or 1. And now, is there an LED that's actually attached to pin 9? That's a really good question. Huh?
I think only pin 13 has an LED.
Well, why did they write this way? Are we supposed to have an LED in one of our handy-dandy fun things to do with it?
He was talking about a mega. Okay, above that, the fade out was initially equals 5, right?
Yes.
Okay. And then we went down to minus 5.
Let me try this with making LED 13.
Okay.
It isn't really fading, but that's probably because the pin is a purely digital pin and not a pin with an analog variation. I didn't realize I was going to need so many props. And that the props weren't handy. I'm looking to see if he has any LEDs working. You doubtless haven't memorized the cabinet well enough to be able to find the LED drawer fast.
Probably not fast, but I can still go look for it.
No, that's all right. We only have 3 minutes. Okay, so maybe in 2 weeks, if somebody really wants to see this actually work, and of course, well, the so it works sort of, but it's not really fading. Okay, so read analog serial. No, I didn't want to do that. Read analog voltage. I wonder in what way that's different. Let's see. Okay. Read analog voltage. Oh, this is the same thing as read analog serial, except they're actually converting it to a voltage.
Well, they're converting the millivolts by, they're dividing the millivolts by the number by the.
No, No, that's not what they're doing. They're dividing the full scale value by the total number of steps in the digitization.
That was what he was telling us earlier, the 5 volts over the 1023.
Yes.
The fraction. I will be back this afternoon.
And they're telling me something about the compiler in doing this. The compiler isn't happy mixing types. You have to convert types before creating an equation. which is interesting. No, it is. It's mixing types, sort of. Now, the smart coder, by the way, if you are speed limited, what you would do is define up here in setup, you would do float cal equals 5.0/1023.0, and then you would, let's try this and then let me show you what that does. So first let's just try this.
I'll see you there.
Right.
Or I'll look online and see you later, Dr.
Okay. Now, where is my... Okay, so now we are getting 3.33 off into the sunset, which is what I'm putting in. And I'll switch to 5. And we're getting 5. And I'll switch to ground, and we're getting ground. So now let me illustrate slightly more efficient coding, because to run real-time coding, you have to use all of this good stuff. So enter / initialize calibration constant. Float cal equals / 1023.0 lam semicolon, and you can go down here, cal. Everybody okay with that? Mm-hmm. Let's see what that does. Oh.
Oh, you forgot to put it in.
I know what I have to do. Wrong. I didn't make the scope global. Actually, I probably ought to. Now, here just defines it, makes it global. It's not going to work. Okay, so what just happened there? The variable cal was in 2 separate subroutines, but it wasn't defined to be a global variable. So the subroutines didn't know where to find it. So what I had to do was define it as a global variable. Now, it's happily running off into the, still doing its thing extremely well. So what we saw here was how to interpret a number. Of course, the fact that I only have 3 voltages available is, well, that's just too bad. I'll bet what's happening too is that what's going on is that the USB line is actually getting this as an RS-232 bit stream. That's how come we're seeing it. Now they're doing it as ASCII characters, which is not the way we're going to do the telemetry. Everybody understand the difference? I want to go kill some member of the CS department, because all of you should know the difference. I remember 40 years ago having fights with the CS department because we employ students as programmers and they would not know what a binary file is. Okay, what is being transmitted over this cable to here and thence to this screen are the numeric representations of the characters, 3.33, carriage return. The numeric representations are in a code called ASCII, pronounced ASCII by all but the most anal retentive amongst us. It's one of several character representation codes used in computers. The other most common is what's called IBCDIC. That's EBSDIC, it's actually an acronym, which is the proprietary coding used by most IBM boxes. And one of life's more fun occupations is writing IBCDIC to ASCII converters. You can't, for some reason, find those out there. If you have to do that conversion, you got to do it. It's annoying. I guess it's the way all of us, meaning senior faculty, torment students. A binary number, on the other hand, is a digital representation of it's actually the number. It can be an integer, which is a number if it's done in 2's complement between plus and minus 32,000, it's a 16-bit number. Or it can be in floating point. Floating point is a representation of scientific notation in which you have you have some number of bits that represent the exponent, and then some other number of bits that represent the characteristic. And now those are much more efficient ways of storing numerical data. And for telemetry purposes and for storage file purposes, that's what all science should use. I believe that's what the IMET uses. But then, so that humans can actually interact with it, you usually represent the data as, well, even if you aren't trying to represent the data as ASCII characters, if you just feed raw numbers to the screen, they will come up as ASCII characters, because that's what screens do. So you take the time to convert your number into a character representation, and that's what this serial print-in is doing. It is taking a numerical binary value, voltage, and turning it into characters. That's like week 1 of any computer use class, or it should be. And maybe that's the problem. It's week 1 and everyone forgets it by the time they graduate.
Yeah, more than likely.
But yes, you guys are going to be working with binary data almost exclusively and only representing it as characters when a human has to interact with it. So understanding the difference, and understanding the difference that's expressed here between integer sensor voltage and floating point voltage is really important too. So anyway, that's our hour, and I guess it's time to. Well, I don't know how to. Meh. Oh well. Okay, so we have gone through all of the basic examples. And they've shown a number of different functions. Now there are a bunch of for 2 weeks from today, somebody ought to go through this and have the parts handy. I didn't know that this was going to take extra parts. You'll be gone already, won't you?
I'll be gone July 7th.
You should be here. Okay, well then you can draft some troops to help you have the parts needed to go through a bunch more of these examples. Your other job is to find a time between now and Friday when I can show some people how to solder. One rule should be if you aren't comfortable soldering, get a lesson first.
I'm off on Wednesday, and I'll be going to.
What do you mean you're off Wednesday? You just made an appointment with me for Wednesday.
No, I mean work. I'm off work.
Oh, that didn't convey I'm off work.
Oh.
I'm off means I'm out vacationing.
Oh.
The
Sorry about that.
we use a very ethnocentric language here. You could even say I'm off means I'm at work. Okay, now here's a good question. Now, if it were me and I was doing this, I would have put in a stop program command.
Maybe just press the reset button.
Yeah, let's see. I don't want to break it by. No, it just started again. Okay, so I guess I'll just unplug it and the hell with it. Okay, so now I need to go to my happy stop broadcast. We're done.